Hello, 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 hello. Good morning, students. Myself, Professor Uday Patel. Today we study about resonant converters. In that, most of the part are already covered in previous lectures, like introduction, need of resonant converters. After then, classification like load resonant converters, resonant switch converter, resonant DC link converter, high frequency link integral half cycle converter. These are the classification of resonant converters. In that we already seen load resonant converters. Sorry, in that we already seen series loaded resonant converter, parallel loaded resonant converter. After then also seen that hybrid resonant DC to DC converter. Okay, and finally the last topic of this chapter is resonant switch converter. In that we uh, we seen zero voltage switching. Okay, and now we will see the zero current switching operation. Okay, as well as diagram of the zero current switching. Okay, first of all we will see the basic concept of zero voltage switching. After then we move forward to the main topic. Okay, now what is zero current switching? Zero current switching is basically what, whenever you close the switch and open the switch, you have some voltage or current in normal condition. Okay, whenever you open the switch and close the switch, you will get some voltage or current. But ideally what happens, okay, if you open the switch, there is no current flowing through the switch. So current passing through the switch should be zero, but in actual condition there is some current which we already discussed in this diagram. Okay, turn off means opening the switch. At that time you get some current, this type of current, and you will got open circuit voltage, or you can say that voltage drop across the switch. Okay, maximum. Okay, but after some time we'll got zero voltage, sorry, zero current. Okay, but whenever you turn off your switch, you will got some power losses. Okay, because of this current and because of this voltage. So you should reduce this power loss by some technique. That's why we are using, or we are using zero current switching, zero voltage switching configuration. Okay, that's why we have to study the zero current switching and zero voltage switching configuration in this chapter. Now we already study this zero voltage switching theory. In that we got zero voltage. Okay, you can see here. Okay, we got the zero voltage across the switch. Okay, now we will study about what, zero current switching. Okay, we already discussed in our previous chapter that in zero uh, sorry, so you can say that in resonant switch converters we are using the step down DC to DC converter circuit. For taking reference of this circuit, we can understand the operation of zero current switching. Okay, so what is DC to DC converter? Okay, many students know this DC to DC converter as chopper. Okay, chopper, it means it convert the DC voltage into DC voltage. But how it converts fixed DC voltage into variable DC voltage. Variable DC voltage means what? It gives you your desirable voltage. But here, this is step down voltage. Step down voltage means what? Buck converter. There are three conventional converter in your chopper. Okay, buck converter, boost converter, and buck boost converter. First one is buck converter, which convert this step down voltage. It means if you give 100 voltage and if you want to sorry, if you want to get 150 voltage, you cannot use this buck converter or step down converter. You have to use the boost converter or buck boost converter. Okay, from this configuration you will only got the less in input voltage. So if you want to give 100 voltage here, and if you want to 90 voltage, 70 voltage, or whatever you want, but based in your input voltage you will get through your step down DC to DC converter circuit. Okay, so this is the basic concept of step down converter, DC to DC converter, and also zero current switching operation. Okay, now the biggest question is how you modify this circuit into your what? Zero current switching circuit. So in that, what happen? If you wait a minute. Okay, if you consider this circuit, and if you consider this circuit, you can see here that both the circuit are same. Okay, only this part of okay, but this part in both the circuit are same. Then what is modification? Modification in this part. Okay, we added one inductor in series with the switch, and we added one capacitor across the switch. So whenever you draw the circuit, you have to remember first step down circuit, okay, or buck converter circuit. First of all, you can draw the circuit, and after then just remember that you have to draw the inductor in series with switch and the capacitor across the inductor and the switch. Okay, so you will get this modified step down DC to DC converter or zero current switching circuit. So we move forward to the main topic now. Okay, this is the different mode for the zero current switching operation. Okay, let me change the pen color. Wait. Okay, right now what will be happen in first mode? Okay, now we will see the waveform for what? IT means what? The current flow through this switch. Okay, remember that IT means what? Current flowing through the switch. After then another waveform is VC. VC means what? Voltage across this capacitor only. Remember. Okay, now in first mode what happened? If you clearly see that the current is flowing through this direction. Okay, this is DC voltage, so the polarity is not changing, it is fixed. So the current is flowing through from what? Positive polarity to negative polarity. Okay, current start flowing through what? Positive polarity, and return back to the negative polarity. Okay, the load will get the energy when the current is flowing through this polarity and return back to a negative polarity. Okay, so consider this. If current is flowing through this direction, okay, current is flowing through this direction, current is first flow to the inductor. Okay, after then current is flowing through this diode, but diode will be off, so current is flowing through this direction. After then current can flowing through this I0 source. Okay, what is I0? I will tell you, but consider this. Then current is flowing through this direction and return back to the main source. Okay, now many students have the question that is this current is not flowing through this branch. Current is of course flowing through this branch, but if you can see the mode 1 VC voltage, there is some already previously charged capacitor is there. That means in some previous cycle capacitor is already charged. So what will happen? The current of VC capacitor is flowing through this direction and it opposes the current of this VD voltage, the main source voltage. Okay, is like if you consider the current flowing through this VD voltage is ID. Okay, consider this ID. Okay, so it opposes the what? The ID current. Okay, so in that what will happen? The maximum current is flowing through this direction, this branch, in that the inductor is present. Okay, so in that what happen? If you consider this is VD voltage, okay, of voltage across the capacitor. Okay, then it is fully charged. Okay, so the voltage across the VC voltage, okay, capacitor across voltage VC is constant in this mode, because this capacitor is not discharging in first mode. Okay, it is flowing only this loop, so it is not discharged in any element. Okay, but in that what happens? The inductor will be in charging condition. It is slowly charged. Okay, so if you consider this in from T0 to T1 time, the current is injected in this inductor and current the waveform of the current is increasing mode, in the increasing mode, but up to T1. After then in T2, what happens? Okay, one more another things. If you see clearly, the current is flowing through this diode and also from this I0. Okay, in this diode is on for fraction of time or fraction of second, but it is on in first mode. Sorry, it was on in first mode because of this source. Okay, when the energy of this current is less than the energy of this I0. Okay, if ID is less than I0, then at, at this condition the diode is on. Okay, but when the condition is change and id is greater than I0, which is in second mode, the diode is erased in the circuit because diode is in off condition. Okay, in first mode, this I0 is greater than the ID. Okay, so diode is on in this mode, but after then the energy of the source voltage is higher than the energy of this current source. Okay, so the diode is off. Okay, at that time capacitor start discharging. Okay, capacitor start discharging because of what? This current in this first mode, the current of the source is only uh, charge this inductor, but if the diode is off and this source will take some energy. Okay, this source means what? this this lf inductor. Okay, the inductor is working as current source here. Okay, so it lose some energy. Okay, so after turning off of this diode, the current is flowing through this inductor, and after then current is flowing through this I0. I0 means LF inductor, which is filtering inductor. Okay, it is also inductor now. Okay, so it can consume some energy. So capacitors start discharging to charge this inductor. Okay, so if you can see that the capacitor gradually decreasing, and the current from the IT means current flow through the this branch is increasing. Okay, at the optimum value at T1 dash point, and at T1 dash point the charge capacitor is fully discharged at this point. Okay, so this capacitor is what? Fully discharged. Okay, and after then what happens? If you consider this, okay, the current is flowing through this direction. Okay, as well as the capacitors give the energy to this inductor. Okay, so at this point the current is fully charged, but after then what happens? If IT current is slowly decreasing. Okay, IT current is slowly decreasing. Why? Because the ID current is flowing in clockwise direction. If this capacitor is discharged, then the energy from this inductor is discharged in same direction, which is charging direction of this inductor. So the current is flowing through what? This direction. Okay, this current is what? IT. IT is decreasing because it charged the capacitor in reverse direction. Okay, you can see here that the current is, sorry, the voltage across the capacitor is increasing in negative. Okay, because of IT current is give the energy of inductor to capacitor in reverse direction. Okay, and also current is flowing through this branch also. Okay, So at T1 double dash point, what will happen? Okay, the capacitor is charged maximum. Okay, and if this capacitor is charged maximum in negative polarity, okay, after then the energy of inductor again decreasing, okay, because the capacitor polarity again change in this manner, okay, and it start discharging in opposite direction of this IT current, okay. That's why this current is gradually comes to zero, and the VC voltage capacitor across voltage uh, which have polarity in negative will start decreasing, okay, because of it discharge its energy to eliminate or cancel out the IT current, okay, and after then the voltage in third mode, what will happen, the uh, because of capacitor VC in this manner is discharging its energy in the reverse direction of the IT current, this switch will be off, and the VD voltage is appear across this capacitor, okay. The polarity is positive and negative now, okay. At this point the capacitor energy is totally in discharge condition, okay. After then the VD voltages again charge this capacitor by this polarity, okay, and it again take the positive voltage across the VC voltage, okay, and current is flowing through this, okay. So we got the VC voltage as positive VC voltage, okay, and again the what if sorry, in the fourth mode, okay, what will happen, the capacitor across voltage is positive VC, okay, and the current is flowing through only this direction, okay, in this loop, okay. At that time the current source is um, give its energy or current is flowing through only by using this diode, okay. And after then the again mode 1, mode 2, mode 3, mode 4 continuously repeating itself. So this is what zero current switching. When you turn off the switch, okay, when you turn off the switch in mode 3, you will get zero current, which is our aim, okay, which is our motive for understand or performing this circuit operation, okay. So we can get the zero current switching, okay, zero uh, current in the sorry, in this particular mode 3 and mode 4, in that the switch is off, and we also got the zero current flowing, zero current, which is actually our aim, okay. I hope you got my point. And this is the last theory, zero voltage switching clamp voltage. we will, okay, sorry, uh, this is one another circuit actually. Okay, you can also modify the buck converter in this manner. Okay, and you will also get the same aim. Okay, aim means what, you will got also the same solution which we got in this theory. Okay, so in the next lecture we will study about the zero voltage switching. Okay, zero voltage switching, clamp voltage. This theory, this is the last theory. We already studied about the zero voltage switching. I hope you understand this here well. If you have any confusion, okay, you can write on in the comment box. Thank you so much.